Well, it's time for you guys to start getting into some kinematics, start doing some classic physics type stuff. So we're going to start looking at kinematics today, and we're just going to start by doing a whole bunch of like grade 11 review type stuff, because of course a lot of the stuff we do in grade 12 is built on grade 11 stuff. So if you remember from grade 11, kinematics is all about motion, and we had four main quantities that we used. Of course, we got the speed, acceleration, time, and distance. And of course, there's also velocity and displacement as well, but there's those four main quantities that we used in kinematics last year, and that doesn't change this year. Kinematics is about those four quantities: things moving, how fast they're going, the acceleration to get there, how long it takes to go distances, that type of stuff. So it's all just about kinematics. And you remember from last year, you guys, you started with, dt graphs, and of course, on your dt graph, the slope, that gave you your speed and stuff like that. And then, of course, you guys had vt graphs, and of course, the slope was the acceleration. And these are all the basic things that you guys worked on last year. So we're just going to kick back into grade 11, practice some grade 11 type questions to get things going again. And that's what we want to do in this video, is just practice some good old-fashioned grade 11 kinematics, okay, before we get to the grade 12 stuff, which is just built on modifications of stuff you guys already worked with. So let's start with a simple type of question. Good old-fashioned DTV and got a good old-fashioned VAT. Those are the two expressions that we worked with last year. Of course, that came out of the DT graph, and of course, you had VAT out of the VT graph. So let's just practice this type of stuff. Nice and simple, no big deal. Okay, so let's start with this. Okay. Alright, so let's just start with some guy running down the street, something really simple, and we'll see if we can work with you guys. So let's see if this guy's cruising along. Let's say he's running at 6.4 meters per second. Let's go really simple. How long would it take for him to go 250 meters, which is way farther than I would ever want to have to run. So how long would it take to go 250 meters? So this is basically, we're looking for time, and we have time in both expressions, but of course this one's got the D and the V that were given, so that's what we would use. So good old-fashioned DTV, so time would just be the distance over the V. We got the distance of 250 traveling at 6.4 meters per second, so we'll just divide those two out, and if we do that, we will get approximately 39 seconds. Okay, so there we go. Good old grade 11. And of course, hopefully remember, typically looking for four main things: formula, substitution, answer, and units. Try and round to 2 or 3 significant figures at the end, and it's all good. Okay, all right, so let's try something else. Let's try something else a little bit different here. Let's go with oops, there we go. Got the road. And here we're going to draw an awesome little car. There we go. Nice little car. All right, and our car is zooming along. And let's say travels for, let's go with 16 minutes, and let's say our car is going 75 kilometers per hour. All right, so we're looking for how far did it go? Okay, well, a couple things kick in that hopefully you guys noticed. First of all, we got that kilometers per hour. You want to convert that into meters per second, and if you remember, with the 3,600 seconds per hour, the 1,000 meters per kilometer, the conversion factor was 3.6. We used that quite a bit last year. So if we divide that by 3.6, we can find out that it's going about 20.8 meters per second. Of course, we want to change that 16 minutes into seconds. And of course, that would be around 960 seconds. And then we're good to go to solve the rest. So if we learn how far, good old DTV, we just have to multiply those two things together. And this thing will go on, we'll round off around 20,000 meters. It's like 19,968. Two sig figs would even be like 20 grand, something like that. Okay, so good old-fashioned DTV. All right, so hopefully this is kicking in some memories of stuff that you guys did last year. All right, well, let's clean this up and do some other stuff. Okay. All right, so let's try this. Okay. All right. So draw a guy up here. Okay. All right, something like that. All right, so here we have a traditional superhero dude type guy. Due to trademark copyright, we won't name him. All right, so here we got a guy right here. Okay, and let's say he is just at rest, and then he takes off flying, and he accelerates at, let's say accelerates at 12 meters per second squared for 7.2 seconds. All right, so let's do a couple things here. So starts at rest, accelerates at 12 for 7.2 seconds. All right, so let's see. Let's start with this. How fast did he end up going? Okay, so basic acceleration type thing. So, of course, look for your change in v, and the change in v, of course, would be acceleration times time. We got the acceleration, we've got the time, we have everything that we need. And if we just multiply those two things together, we find out he ends up going 86.4 meters per second. Okay, basic acceleration, no problem. Okay, well, then how about this? How far did he go? All right, so good old-fashioned DTV. So looking for this. Now, of course, the kicker for this, hopefully remember, when using DTV, you've got to be very, very careful. There's a reason why you'll often see this expression with a line up top there, because that means average. Remember, DTV is either based on constant speed or average speed. And our super guy here, he started at 0 meters per second, and he went all the way to 86.4 meters per second. And we'd want to use the average, which is right in the middle, which of course is 43.2 meters per second, and that's the one that we'd want to use over here. Okay, so gotta remember, if it's not constant, you want to use the average v, and since he's starting at 0, it's really, really simple. So the time hasn't changed. The time is still the 7.2 seconds. We use the average v of 43.2, and then we just got to multiply those two things together, and he ends up going around 311 meters. Okay, how's that? Okay, basic grade 11 review, DTV, VAT. All right, let's try another question. All right, so let's try this. Okay, draw, got a little pumpkin. All right, okay, so got a pumpkin running down the street. Let's say our pumpkin over here is going, let's try this. Let's say our pumpkin is going 8 meters per second. Okay, so our pumpkin's going 8 meters per second running along. All right, and let's say our pumpkin goes 60 meters. Let's see, our pumpkin travels 60 meters in, let's go with Let's say 5 seconds. Alright, so our pumpkin went 60 meters in 5 seconds. Starts at 8 meters per second. What is the acceleration of the pumpkin? Okay, well, let's look. We get the 8 meters per second, so that's my first V. But I got distance and I've got time. And of course, with distance and time, it's really easy to calculate average V. So you got the 60, and we'll divide that by the 5, and that gives us 12 meters per second. Of course, that 12 meters per second, that's my average V. So hopefully this is going to look familiar. Our pumpkin was traveling 8, and it goes up to something we don't know, but the average right in the middle was 12 meters per second. So it's 4 more from 8 to 12. There's a gap of 4 here, which means there's a gap of 4 here. So this has to be 16 meters per second. So it ended up going twice as fast. So it went from 8 to 16. So the change in V was also 8 meters per second because it went twice as fast. Okay, so hopefully that little diagram, we drew that quite a bit in grade 11. Nice little visualization of how the numbers sort of relate. So with this then, acceleration of course is change in V over change in T. And my change in V is 8 because it went from 8 to 16. My change in V would be the 8. I'll divide that by the 5. And if we divide those two out, we'll get 1.6 meters per second squared, something like that. Okay, good old basic kinematics. All right, let's try some more stuff here. Let's get rid of this. Okay, well, how about this? Let's try something else. Let's try. We can use that. Something like that. All right. Okay, so here we got a B. All right, just a little B, something like that. All right, so our B is flying around, and let's say our B is traveling at let's go 7.5 meters per second, a nice fast B. And let's say our B accelerates, and let's say it accelerates at 1.4 meters per second squared for let's just go with 3.5 seconds. Okay, so do something similar as before. So we're looking for how far did the B go? Okay, so let's try this. All right, so let's see. We got a couple things going on here. We got initial speed of 7.5. Right there, though, I've got my acceleration. I've got time, and acceleration and time are great for finding change in V. So I just multiply those two together. I get a change in V of 4.9 meters per second. So I'm going to lay things out again. Our B was going 7.5. And it speeds up, and the change in V was 4.9. So I just have to add that to my 7.5, and I can find out the B ended up at 12.4 meters per second. Okay, so now that I know that, it started at 7.5, ends at 12.4, so I can just find the average of the first and the last speeds, and that'll give me my average V. So right in the middle here, my average of 7.5 and 12.4 will give me 9.95 meters per second. So that's my average V. All right, so I like to lay out all my V's and stuff like that and see all of my change in V, average V, first, last. I like to be able to lay out my V's. All right, so now that I have that, I can find out the distance. Of course, good old DTV. Time. Same time as before, no big deal. Average V would be that, well, it's basically 10 pretty much, is what we're going to end up with here. 9.95, so we'll multiply the 35 seconds times 9.95. I don't really need to worry too much. It's going to end up being around 35 meters is how far the B will have gone. Okay. All right, so let's try something a little bit different. Okay, let's try this. So let's draw some ground like this. All right, here we have a nice little tree, branches and stuff. All right, need some leaves up there from Mr. Tree. There we go. Over here, draw a big rock over there. Okay, and you are going to be over here. Okay, there you are. And you've got a bow and arrow. And you have shot an arrow. Now, the arrow, for some reason, you decided to try and shoot a rock with an arrow, which isn't actually the best idea, but whatever. So you shot the arrow. The arrow went straight across, hit the rock, and then end up going straight up. And the arrow has stuck into the tree, something like this. Okay, so when you shot the arrow was traveling at 32 meters per second, and it did that for, let's say, 1.4 seconds. Okay, then it hit the rock and went straight up, and let's say it went straight up, and it went 12 meters, and it did that in, well, it'll be a little bit slower, I guess, but we'll see how this goes. It did the 12 meters, let's say, in 0.85 seconds. That's for that part over there. Okay, so what I want is, what is the average speed for the arrow, and what was the average velocity for the arrow? Okay, so kicking back to good old grade 11 again, let's see if we can figure this out. Okay, so first things first, I'm just going to solve for a couple things, see what we can do. Like for the first part there, I've got the there we go. I've got the speed and I've got the time, so I can find a distance. There's no acceleration in this at all, so I'm not going to worry about that. So for this part right here, I can find the distance for the first part, and it would just be the first time multiplied by the first speed. So I've got the 32 times it by 1.4, and I've got a distance of 44.8 meters. All right, so that's using those values. Now for the second part, I've got distance and I've got time. I could solve for my average speed for the first part. So if I find more, or second part, if I do that, I'll use my second distance and my second time. I've got the 12, I'm going to divide that by 0.85, and I get around 14.1 meters per second. All right, so now I've solved for stuff for both. Whether I need all of this or not, who knows? I'm not going to worry about that. But if I can solve for some things for each part, why not solve for some things? Okay. All right, so now let's get into the two questions. So first of all, average speed for the entire thing. Now, of course, the terrible thing to do is take the first speed and the second speed, add them up, divide by 2, and that's not going to work because one lasted for way longer. So if you remember from last year, what we want is the total distance and the total time. So I've got both my distances, that's perfect. I've got the 44.8 and I've got the 12, so I can add those two distances together, which of course would be 56.8 meters. And I've got my two times. I've got the 1.4 and I've got the 0.85, so add them together, which is 2.25 seconds. So total distance and total time. And if we divide those two out, we will get about 25.2 meters per second, and that would be my average speed of my arrow. Okay, well then, what about average velocity? Okay, so for average velocity, if I want my average velocity, instead of distance and time, of course, we want the total displacement and time. So I need my displacement, which means I got to do some vectors here. So I know my first my arrow went this way. 44.8, and then it went up 12 meters, and then it means I need to find my resultant vector, which of course goes across there. So if I do my basic Pythagoras and trig and blah blah blah, the displacement from beginning to end using Pythagoras is about 46.4 meters. And this angle in here is like 15 degrees. So that would be my displacement. That's what I want to use in my displacement calculation. So over here, this would be 46.4 meters. Time is just time, no big deal. So we'll divide out the 46.4 and we'll divide that by the 2.25. And we will end up getting about 20.6 meters per second. At the exact same angle, nothing wrong with 15. It's going up from the positive x direction, no big deal. So the average velocity would be 20.6 meters per second at 15 degrees. Okay, so again, very basic grade 11 review. This is approaching probably the larger type of kinematic questions you guys did last year. But if you guys remember, it's just the same basic formulas over and over again. All right. Okay, let's get rid of this and try something, a couple more questions at least. All right, so let's get rid of this. All right, let's try something else. Okay, so how about this? Just one tool. All right, let's get some road going on. Okay, all right, let's try this. A couple wheels. All right, something like this. Bars. All right, so here you are on your little scooter over here, and you're cruising along pretty good. And let's say you're cooking it at 8.2 meters per second, and then over here, like that, all of a sudden in the middle of the sidewalk, you've got a little baby duckling from one of the retention ponds across the street, and you gotta slow down. So you don't have a time here, but let's say you're gonna slow down, and you slow down to 1.6 meters per second, and don't worry, you don't hit it or anything like that. You slow down to 1.6 meters per second, and let's say you were, let's go with 14 meters away. All right, so what acceleration did you use to slow down? Okay, well, let's just start by looking at some things I have. I got a couple of V's. I got my first V of 8.2, my final V of 1. I'm going to sort of lay out my V's here. Went from 8.2 down to 1.6. So I'm going to find my V's here. Just with that alone, I can find out my average V. So 8.2 plus 1.6. And we'll divide that by 2, cut in half. So we got average V was 4.9. Even if I'm not going to use it, I like just mapping out my V's just in case I do. I can also get my change in V between the two. So if I subtract the two, I've got a change in V of negative 6.6, of course, because you're slowing down. So something like that. Okay, so there's my V's. So let's see what I can find out here. Well, I haven't used my distance yet. Well, with distance and average V, I can find time. So let's see what I can do with that. So time would be distance divided by the average V. So I've got the 14. I'm going to divide that by the 4.9. And it looks like around 2.86 seconds. Okay, so now I got time. So let's see. I'm looking for acceleration. Do I have everything for acceleration? For acceleration, I would need change in V. Oh, yeah, I got that over here. I need my time. Oh, that's over there. Actually, I'm good to go. So my acceleration would be change in V over change in T. So I'd want to take that 6.6 and divide it by the time I just found. Divide the two out. And we're looking at around 2.3 meters per second squared. And since he is slowing down, that would be a negative acceleration. All right, so there you go. basic DTV VAT again. Okay, let's try something else here. Divider. Okay, so suppose we have a, let's go with a little spaceship. Oh, that's just terrible. Let's try that again. Alright, let's try, well, that's a little better. Okay, suppose we have a little spaceship going on, little alien buddies. Alright, so it's traveling along and moving along, and let's say it accelerates at 3.5 meters per second squared for 5.8 seconds, and it reaches 30 meters per second over here. Let's find out, maybe we'll find out a couple things. Well, let's see how it goes. Let's see if we can find out how far it went. Okay, let's see if we can figure that out. Okay, well, let's see what we got here, see what we can piece together. Okay, well, I've got my final V, I've got acceleration, I've got time. Well, right there, acceleration and time. Acceleration and time, of course, go really nicely together to find my change in V. So change in V would be the acceleration times the time. So that would be the 3.5, and we'll times that by the 5.8. And we have a change in V of 20.3 meters per second. So I know my little ship cruised along, ended up at 30 meters per second, and the change in V was 20.3. So if I just subtract that from the 30, I know that my ship must have started at 9.7. So it started at 9.7. It changed by 20.3 to reach that 30 meters per second at the end. Okay, well, now that I have my 9.7 and I've got my 30, I can just add those two together and divide by 2 to get my average V for the situation. So my average V is 19.9 meters per second. So actually really close to the change in V again. So 19.9 meters per second for my average. Well, now that I have that, of course, distance is DTV. I have my time, which is 5.8 seconds. Average V of just under 20. So let's multiply those two together, and we will get approximately 115 meters for distance. Okay, so there's some more practical basic DTV VAT. And again, like these two equations are the basic fundamental ones from grade 11. They never go away, no matter how far you get along in physics. They're always sort of kicking around and are really, really handy. Okay, and of course, just practicing their basics and remembering, the difference between change in V, average V, drawing things out really, really helps. Try and keep your stuff, neat and organized. And hopefully this rings a few bells from last year.